views can be used in engineering drawings to supply information about local geometric items, such as internal features, profiles or shapes. Consider an object intersected by a plane. When the object is cut off by this plane, the remaining part will contain a face at the location of the cut. The orthographic projection of this face is called a section view. The plane used to cut the object is called the cutting plane. Engineering drawings will show section views without the object actually being physically cut. This means that the shown face will never be visibly present in the documented object, but is hidden inside the geometry. In the example, the cutting plane is present in the front view of the object. It is drawn using a thin chain line with thick ends. Arrows are drawn perpendicular to the chain line to indicate the viewing direction. The arrows are accompanied by two letters, which are repeated as the section view name. The contours of the section are filled with a hatch pattern. The hatch pattern is drawn with thin, continuous lines. Typically, a 45-degree angle is used for a hatch pattern. An engineer has the option to show or not to show the geometry of the object being drawn in the background. In the example, a small portion of the object is shown to the right of the hatched area. This represents the remaining slanted face, so in this case, the background is shown. The background is shown by default, unless it reduces the communicative value of the section. In CATIA, the 3D application with which you will be working later during this course, sections showing the object's background are called section views. Sections where no background is shown are called section cuts. The location of the section view in the drawing layout depends on the projection method used. If the American projection method is used, the position of the section will be such that the arrows at the cutting plane point away from the section view. For the European projection methods, this is exactly the opposite. The arrows will point towards the section view. Our faculty uses the American projection method. In the example, the viewing direction is from up to down. Without sectioning, the top view would be visible in that viewing direction. The position of the top view in American projection is above the front view. It makes sense the section view with a similar viewing direction should also be located above the front view. Section views should preferably be placed outside the normal orthographic projection views. So if both top view and a section view are present, the top view is located directly above the front view and the section view is located above the top view. Offset section views can be used to reduce the amount of required views to document an object. 3 holes are present in the triangular crank. A single cutting plane line can be drawn, changing direction at 2 points to intersect all 3 holes in one go. The corners at the change of direction are thickened, similar to the line's ends. In the section view, center lines indicate the location of a change in direction. Aligned section views are used in the case of a circular object. Consider the example shown. 2 hole patterns are present. The cutting plane, indicating the location of section view AA, starts vertically at the bottom until the center of the object. From the center, the cutting plane continues in a slightly angled trajectory to intersect one of the smaller circles in the drawing. In this way, the section view shows information about 2 different holes in a single projection view, without the holes being actually aligned. The section view is not foreshortened, but shows the geometry as if the cutting plane was vertical. This would be different in the case where the object was cut off in reality. The projection of a real cut, which, as a result, will have a face not perpendicular to the projection direction, is foreshortened. Section views can also be used for assemblies. Make sure to use a different hatch pattern direction when 2 adjacent parts are sectioned. The preferred way to do this is to use a 45-degree angle for the first part and a 135-degree angle for the second. In a case where more than 2 parts are sectioned, the pitch between the hatch lines of one of the cut parts should be changed. If 2 areas in a drawing contain the same kind of hatching, this means that the 2 areas belong to the same part. Different hatching is used to indicate different parts. Some geometrical items may never be cut in section views. Solid cylindrical items, such as bolts and shafts, are not cut, which means they are projected normally, not showing a hatch pattern, but showing the visible outlines and contours. Nuts and washers are also not cut. Other examples of geometrical items which may not be cut are ribs, webs, and spokes. Ribs or webs are thin-walled features, commonly used for reinforcement purposes. Spokes are rods radiating from hub to rim in a wheel, such as those seen in a bicycle wheel. Partial section views can be used to show the internal geometry of an object within a projection view. Partial sections do not have section planes. The view is shown with hatching at the section geometry and is delineated using a line in zigzag or thin irregular line type. Sometimes other projection views can be seen in engineering drawings. As well as section views and the orthogonal projection views such as front, left, right, top, bottom and rear view, detail views can be presented. If the detail is present in a certain projection view, this is the origin view for the detail view. In the origin view, a circle or another geometric item is drawn with the thin continuous line type to indicate the detail's position. A letter is present with a leader pointing to the geometric item. This letter is repeated at the detail view. The scale used to represent the detail is bigger than the origin view's scale, so all items are shown bigger. The limit of the detail view is the same geometrical item as the item used to indicate the position in the origin view, but instead of drawing the complete item, only the parts which intersect the shown object are drawn. Partial views or clipping views can be shown to reduce a drawing's size. Non-relevant items are cut away from the view. In CATIA, partial views are delineated using a thin chain line. Auxiliary views can be used if the orthogonal projection directions are insufficient to give a clear representation of an object. Auxiliary views are indicated by an arrow in the viewing direction, accompanied by a letter. The letter is repeated at the auxiliary view. The object is projected in the direction of the arrow. In the example shown, the fork depth can be dimensioned in the auxiliary view because no foreshortening occurs in this view.